Today we'll be replacing the EVSE Level 1 J1772 plug for the GM 110 volt portable chargers that are used in their hybrid vehicles, Chevy Volt, and Cadillac ELR. In general, that should apply to any EVSE Level 1 J1772 plugs. This video is purely for entertainment purposes and not as a guide to repair. I assume no responsibility for any use of this video, and I do not advocate attempting to repair yourself, whether you consider yourself to be qualified or not. The reason I'm replacing the plug is while the car was at home in my garage, the plug was bumped into, and the first time the retaining latch was broken off. The second time the whole front end of the plug was broken off, including one connector pin, and rendering it completely unusable. There have been some changes to the charger over the years. Some connecting pins are apparently soldered and some are crimped. The manufacturer of the GM charging unit, which is not GM itself, won't sell any parts for repair or replacement, so I found a replacement plug online. Here's the original. I was hoping originally that I could, like, maybe epoxy this and fix it, but the fact that one of the pins was pulled out, it's crimped. Then when we open this up, you'll see I've taken the screws out already. GM has made this completely, as far as I'm concerned, it's one of the first times I've seen no user serviceable parts inside that's actually been true. 2 screws on the bottom, and this shell comes apart. See, it's screwed in like this with 4 screws, 1, 2, 3, 4. Those you take out, those are Phillips head. Then the little spring falls out, you don't want to lose that. Eventually you split this plastic case apart, and this is a bear because I'll show you here in a second. They potted this with some kind of rubber-like compound that I don't know how I would take this apart. Maybe if I heated this up with a heat gun I could melt it. I'm sure they did this to seal it up and make it waterproof, because obviously the water is going to get down in here if it rains while this thing is plugged in and it's outside. It doesn't matter if this button's on here or not. That's probably why they took this approach. Okay, here's the new connector, the new plug. I've taken the screws out. There's 5 long screws, 2 short screws. The 5 long screws go on the top, 2 short screws down here at the bottom of the connector. This thing just peels apart. Okay, so with inside the unit, there's a strain relief for the cable coming in. I think I'm going to replace that with the strain relief from the original, because the hole in here is the right size. This is the actual connector. Then there's the rubber gasket. You can pull the rubber gasket out. Rubber gasket looks like it's going to be great. The wires that come in here are probably going to be sealed really well. And then this inner piece of plastic comes. This other inner plastic comes out, and then you've got the pins. The pins are now available. These are the ones we're going to crimp to the wires. And you can pull these out with one of those pair of pliers, and you see there's an O-ring on each one of these to seal it off. And you just put these in and crimp them. So I'll take all these out. Here's an EVSE J1772 schematic diagram by David Andrea from Wikipedia showing the standard's detection and control circuitry. There's a lot more on Wikipedia describing the standard. I'm only going through what I needed to know. Left-hand side of the schematic diagram depicts the detection circuitry for the EVSE portable or fixed installation power unit, which is connected to the electrical service. Right-hand side of the diagram depicts the detection circuitry on the car. Notice it's not shown here, but the battery chargers on the car itself. AC power from the electrical service is supplied on pins 1, 2, and 3 of the diagram.
Two blocks in the center of the diagram depict the J1772 plug on the left and receptacle on the right. The receptacle is on the car. The pilot control circuit tells the car what the input voltage and current capability of the supply side are. The portable charging unit from GM has a fixed square wave generator that provides a signal to the car which is interpreted as 110 volts AC at 15 amps. The proximity detection circuit informs the car that the connector is absent, present, or about to be removed. The circuit uses a voltage divider in the J1772 plug and in the car. When the plug is removed from the receptacle, the voltage between the two resistors is determined by the ratio of R4 and R5, approximately 4.5 volts. When the plug is inserted into the connector, the voltage is determined by the ratio of R4 and R5 paralleled with R6, or approximately 1.5 volts. When the button on the plug is pressed, the voltage is determined by the ratio of R4 and R5 paralleled with R6 plus R7, or approximately 2.75 volts. Important point to note is that if the resistance of the plug alone between the proximity pin and ground is measured, there will be 150 ohms with the button up and 480 ohms with the button down. This depends on the tolerance of the resistors, but should be fairly accurate. So this is a YouTube pictorial schematic by Brian Mathis. It's a pictorial diagram of the GM implementation of the SAE J1772 plug. The LED GM added to illuminate the receptacle is not part of the SAE J1772 standard. It is, however, a good idea on GM's part and makes it easier to plug in the dark. The LED is not used on the replacement plug, and there is no good way to retrofit it there, so the pictorial diagram can be modified by removing the LED and associated wiring. Note the gray wire with the purple stripe, EVSE side, is now unused, and one leg of the switch is tapped into the protective earth ground wire. This is the replacement J1772 plug manufacturer's diagram for the switch wiring. PP is proximity pilot, that's the gray wire with the purple stripe. CP is control pilot, that's the black wire with the purple stripe. PE is protective earth, or the grounding conductor, colloquially called ground, the green wire. N is neutral, or the grounded conductor, the white wire, and L is line, or hot, the black wire. If you're working with a non-GM EVSE device, the colors of the wires may be different. Note that the red wire on the switch is connected to protective earth, or the green wire. The yellow wire from the switch is connected to the proximity pilot pin. This is a picture of the business end of the J1772 plug. This will always be the same regardless of manufacturer and is required by the SAE J1772 standard. Clockwise from upper left, L1 is line, hot, black. N is neutral, grounded conductor, white. CP is control pilot, black with a purple stripe. PE is protective earth, grounding conductor, green. PP is proximity pilot, gray with purple stripe. Note that when you're inserting the pins from the back of the connector, you will be looking at a mirror image of this pinout.
Here's the wires laid out. You won't be able to see it on the video, but white is neutral, and that's marked with an N on the plastic here. L up here for hot, and that's the black. Green down at the bottom is marked PE on the plastic, that's ground. Black with a purple stripe is the control pilot. There's another wire that is
the proximity pilot.
Gray with a purple stripe. That connects to the yellow wire on the switch. The red wire on the switch connects to ground. I've cut this wire off down here, the gray with the purple stripe, because that was used by GM to bring power up for an LED that was on when the switch was actuated, but this doesn't have an LED. Now, the connector shell goes in here like this, and notice that I've got the gasket assembly so that it is flush with the back of the shell when the shell is laid into place. These crimped connections are going to go onto these wires, and they'll be down inside black plastic. So what I'm going to do is cut all these wires off flush, slide this down, crimp them, plug them into the connector, and then we'll slide everything up. So all the connectors are crimped on. That's the control pilot wire. There's the proximity wire. I use this. I've had this for a long time. This is a nice green Lee ratcheting crimper. It did great. You might be able to use something like this, a non-insulated crimp right here, but man, you'd have to really bear down on that. You'd have to be pretty strong. One thing I should mention, before I crimped this green wire, I put a piece of heat shrink, I slid a piece of heat shrink tubing over this, because what I'm going to do is cut the insulation away and solder that red wire from the switch. This red wire from the switch needs to connect to the ground wire. Okay, so the first piece of the first plastic retainer down there, that holds all the pins in, and then you slide the gasket into place, and then this retainer holds the gasket down, squeezes it good and tight so that the wires are sealed really well, and so this thing is all really watertight now. You can see I've wired up the switch. The yellow wire goes to this gray wire with the purple stripe. The red wire is tapped into the ground wire. I just stripped some of the insulation back. Now you see why I had to think ahead and put that piece of heat shrink tubing on there so that I could tap into that ground wire. And you got to think ahead when you're doing this stuff, because once you crimp it, they're done. And this heat shrink tubing is the kind with a sealant built into it. I don't know if you can see that on the video, but there's a little clear stuff coming out the ends. It's all sealed. It's all watertight. So now I just put the switch back where it goes, and then I'll put the other shell on there, and we should be ready to go. I'll test it out a little bit. First thing, we'll get the just using the paper clip here, proximity pin and ground. And 149 ohms, push the switch, 482 ohms. So that's right. And I've looked at the mechanical diagram to make sure that I'm on the right pin there. Alright, I got my repaired charger hanging there. I don't think I'd leave it that way, but it works okay for right now. With the new connector. And here's the volt. And here's the charging port. And plug it in, and this plugs in a little tighter than the other one. Yellow light and green light. That looks good. Step inside here. We're charging. Let's see, energy level. We're at 8 amps. Try 12 amps. Everything still seems to be good. I'll leave it on 8 because I got that refrigerator on there. And one day I'll actually have a 220 volt charge, but everything seems to be working good.
For this project, I purchased replacement EVSE J1772 plug, clear plastic tubing. I used the tubing to increase the diameter of the SVSE cable for the clamp and the replacement plug. Liquid electrical tape. I decided to go back and pot the end of the cable from the SVSE unit with some liquid electrical tape where the insulation is stripped back and a little piece of clear plastic tubing I used for the cable clamp. Finally, heat shrink tubing with sealant. That's a total outlay of $111. I'll use the tubing, liquid electrical tape, and heat shrink tubing on other projects. The tools and materials I already owned: a number 10 and 15 Torx, needle nose pliers and wire cutter, a crimper, The Greenlee shown here is the right tool for the job in my opinion. A wire stripper. I need a better one and should have bought one for this project. A knife or razor blade. A heat gun. That's for the heat shrink tubing. Electronic solder and flux. Always use soldering tools and materials meant for electrical and electronics work. This is a 1 pound spool of 6040 rosin core 31 thousandths diameter solder. It's an excessive amount for this project and has lasted me several years. A soldering iron. In addition to the soldering the switch wires, I decided to go back and solder all the pins as well as crimping them. This ensures a good electrical connection and prevents corrosion of the copper wire. I was mindful of the rubber O-rings when soldering the pins so I didn't melt them. It wasn't really an issue with the small soldering iron like this one. A multimeter. I checked the pins on the original plug to the wire colors on the original cable, and I double checked my proximity pin and switch wiring with this high-end Fluke recording multimeter. It's excessive for the average person in this project. A $20 digital multimeter from Amazon would have been sufficient. The total for all the tools and materials here is $416. Which is essentially the cost of a new GM portable SVSE unit. From a single transaction perspective, and purchasing everything here would not have been worth it unless I amortized the cost of the equipment and leftover materials and other projects. Not including putting together this video, the project itself took around 6 hours. About half of that was online research of the EVSE J1772 standard, looking for information from anyone having attempted this repair before, and finding a source for the replacement plug. Delivery of the replacement plug took about a week, during which time I was not able to charge the Volt's battery and had to run on gasoline. The remaining 3 hours was spent effecting the repair itself. I could have spent that 6 hours in leisure or other economically productive activities. There are, of course, some intangible benefits like self-satisfaction, the learning experience, and reducing my environmental waste stream. If you like this video, I'd appreciate a thumbs up. I plan more videos of projects like this one in the future, so you might also be interested in subscribing to my channel.